Welcome to This Explainer, where we are going to uncover how artificial intelligence is finally fixing our broken daily commutes. Look, if you've ever gripped your steering wheel in pure frustration, just trapped in this endless gridlock with literally nowhere to go, you are definitely not alone. Today, we're zeroing in on this exact problem of urban gridlock and the incredibly fascinating, high-tech AI solutions that are untangling our streets.
Think about it. We carry supercomputers in our pockets, we're streaming high-definition video from anywhere on Earth, yet we are constantly relying on this reactive, blind urban infrastructure just to get to work. Seriously, why are we still sitting at a red light when there is absolutely no one else on the road? Well, the answer is that the system controlling that intersection was programmed for a world that simply doesn't exist anymore.
And the cost of this outdated setup? It is massive. The average American loses a staggering 26 hours to road congestion every single year. In cities all around the world, from Bangalore to Mumbai to New York, this lost time translates to billions of dollars in lost economic productivity. Not to mention spiked carbon emissions and, soaring stress levels for drivers. The whole guess and wait era of traffic management is clearly failing us.
Section 1. The reactive traffic problem.
So, there's this really stark contrast between our old virtual loops, which act like simple tripwires, and AI's network-wide predictive trajectory tracking. Traditional systems basically rely on rigid, fixed-time schedules or basic cameras that just draw pixelated lines on a screen. They only trigger a signal when a vehicle crosses that exact spot. AI, on the other hand, it uses high-definition computer vision and radar to map exact vehicle trajectories and approach speeds from up to 800 feet upstream. It's like giving the intersection a pair of smart glasses.
The crazy part is, old tech actually causes gridlock because it completely lacks the foresight to clear the way for incoming bursts of traffic. Say an accident happens, or a massive concert lets out. Isolated intersections just can't communicate with each other. The system has no clue that a massive 40-car platoon is bearing down on it in 2 minutes. It just knows one single car is waiting right now. And that ripple effect, that is exactly what creates gridlock.
Section 2. How AI perceives and predicts.
To actually fix this mess, we need to understand the new AI brain that's bringing these intersections to life. It works in 3 steps. It perceives using computer vision, predicts future congestion using neural networks, and then decides by making real-time adjustments. Basically, deep learning algorithms analyze camera data to see what's happening in the environment. Then, long short-term memory networks, or LSTMs, which act kind of like a short-term memory for traffic patterns, forecast what's going to happen next. Finally, the system decides on the absolute best signal timing to keep everyone moving smoothly.
All of this vast amount of data creates what we call a digital twin. This is super cool because it allows city planners to accurately simulate and test out scenarios without ever touching a real road. Imagine having a dynamic, living digital replica of your entire city's traffic network running inside a computer. It allows the AI to safely test exactly what happens if it, say, holds a green light for 5 extra seconds during rush hour, just to see the impact.
Now, you might be thinking it's just watching cars. But the AI is actually proactively ingesting everything from weather shifts to social media feeds to anticipate disruptions before they even happen. The system pulls in historical data spanning up to a decade, combined with mobile GPS trajectories and real-time incident reports. So it can literally predict a traffic jam forming because of a sudden rainstorm or a localized event. It's incredibly proactive.
Moving on to Section 3. Reinforcement learning at intersections.
Instead of relying on rigid, pre-programmed schedules, the AI learns by doing. It constantly extends or ends green lights based on actual demand. By utilizing deep reinforcement learning, the AI agent interacts directly with the traffic environment. Think of it like a game. It gets a reward when wait times drop and traffic flows smoothly. Over time, it learns to create these dynamic green bands that seamlessly flush traffic down entire urban corridors.
Now, this entire digital handshake happens right at the edge compute layer. What that means is the heavy processing is happening in a physical box right there on the street corner, not in some distant cloud server. And that's absolutely crucial because you really can't run real-time intersection logic on the cloud. The risk of network dropouts is just way too high. The local controller keeps absolute authority over safety, like pedestrian crossing times, while the AI sends instantaneous requests to adapt the green lights with literally zero latency.
Section 4. Real-world smart city successes.
Let's look at some real-world results. In Delhi, AI is untangling highly chaotic, non-lane-based traffic, and it's slicing average wait times by a massive 42%. Delhi's traffic is incredibly heterogeneous. You've got cars, buses, auto rickshaws, and bicycles, all mixing together opportunistically. Traditional math models completely fail here, but the AI system used YOLO, a real-time object detection system, to identify the different vehicle classes, learn the chaos, and actually drop average wait times from 118 seconds down to just 68 seconds. That's a huge win.
Meanwhile, over in Hangzhou, Alibaba's ET City Brain dynamically clears paths for emergency vehicles, which is helping rescue teams arrive a full 7 minutes earlier. By integrating video footage with alarm data in real time, the system creates a free passage for police, fire, and medical responders by literally parting the sea of traffic lights ahead of them. So this isn't just about convenience. That is technology actively saving lives.
It's fascinating because AI acts as this invisible hero, giving human engineers almost godlike visibility over thousands of intersections simultaneously. Google's Project Greenlight is partnering with cities like Manchester, Seattle, and Jakarta. Because the AI analyzes driving trends across thousands of intersections all at once, engineers can implement system-wide optimizations in as little as 5 minutes using the hardware they already have.
Section 5. Beyond just beating gridlock.
Now, sitting idle at red lights isn't just annoying. It creates localized pollution zones that are incredibly toxic. The transportation sector accounts for roughly 27% of global greenhouse gas emissions. And get this? Greenhouse gas pollution at city intersections can be up to 29 times higher than on open roads. About half the emissions at intersections come entirely from the simple act of stopping and starting your car.
So by reducing stops by up to 30%, Google's Project Greenlight is saving fuel and lowering emissions for up to 30 million car rides every single month. Across the 70 intersections in 12 cities where this is currently live, they are seeing up to a 10% reduction in overall emissions at those specific spots. I mean, that is literally a massive breath of fresh air for urban dwellers.
And it goes beyond just emissions. These digital twins can proactively predict accident hotspots and save lives on incredibly dangerous roads. For example, Indian highways see roughly 200,000 fatalities a year. By ingesting massive arrays of historical and real-time data, AI digital twins can actually predict the likelihood of an accident at any given point along a highway up to 12 months in advance. This allows police stations with limited resources to position themselves exactly where they're needed most.
To wrap up our explainer today, I want to leave you with this final thought. Imagine a future where physical traffic lights disappear entirely, and your vehicle seamlessly negotiates its own path through a perfectly synchronized smart city. We're rapidly moving away from that old guess and wait infrastructure. As AI continues to evolve, predicting our needs before we even turn the key, the daily grind of the urban commute might finally become a thing of the past. Thanks for joining me on this deep dive into the technology powering our streets.